Dividing decimals. Again, like multiplying, we first look at dividing by powers of 10 because it's nice and easy. We'll also check our answers where we've got interesting strategies with a calculator. Now you can see that 20 divided by 10, we don't have any decimals involved. This one's there to show you why this works. We know 20 divided by 10, it's 2. You'll remember that when we multiplied by powers of 10, we had a trick where we could take the decimal point and move it, the number of zeros in our power of 10, towards the right to make a bigger number. When we're dividing, look at what's happened to my 20. If you considered 20 as having a decimal point just after the 0, which it does, 20.0, that makes it easier to see. I've moved my decimal point one space to the left, and I've got 2. So you can see that it works if we just move our decimal point to the left when we're dividing by powers of 10. So 2.5, pick up my decimal point, move it one spot to the left because I'm dividing by 10, which has 1 0, and I'll get sorry about my dodgy writing, 2.5. And if I've got a point with nothing in front of it, a 0 in front, just so it's easier to read. Sorry about my writing. Look, 0.25, much better. So 0.02 divided by 100. If you want, you can rewrite it to have somewhere to jump your decimal point. 2 zeros, so 2 spots to the left to make a smaller number. I've jumped over a space, so I put a 0 down. And remember, if we end up with nothing in front of our decimal point, we'll have to put a 0. Don't leave your answer like that. That's not an answer, that's just how you get it. 0.0002 is the answer that we got there. And let's just check that on the calculator. 0.02 divided by 100 equals, oh, well, that's not very helpful at all, is it? This calculator is given in scientific notation. We'll go back to a much simpler calculator. Sorry, we were testing that 0.02 divided by 100 equals, yes, it equals exactly what our method says it did. So we can use that jumping the decimal point to the left to divide. Now if we're dividing decimals by a whole number, for example 56.34 divided by 3, divide it exactly as you would a normal integer. Set up the algorithm. So our little division sign, 3 into 5 goes once, leaving me a remainder of 2. 3 into 26 goes 8 times. 3 times 8 is 24, so that leaves me a remainder of 2. 3 into 23 goes 7 times. Oh, another remainder of 2. And 3 into 24 goes 8 times. Now the answer obviously isn't 1878. The decimal point goes exactly above the decimal point in the question. And if you're afraid that you're going to forget it, stop and put it in, even at the start if you'd like. So just divide as you would normally and keep those decimal points aligned. Now, dividing decimals by a decimal we just don't like to do. So there's another little trick we can do to make it easier. Let's just work out what our example answer will be. 27.354 divided by 0.02 equals, well, quite a lot really. And you might say, well, how does dividing end up so big? Dividing by a number that's less than 1 gets you a bigger result. Now, the easiest way to divide by a decimal is to multiply both sides by powers of 10 until we're not dividing by a decimal, we're dividing by a whole number. Let me show you. We multiply both numbers by the same power of 10. That means a number with 1 and some zeros after it. Or we could say we multiply them by 10 the same number of times. So, sorry, moving the mouse around there. So we change the divisor, the number we're dividing by, to a whole number, and then we'll divide. So it sounds a bit complicated. How many times would I have to jump my decimal point in the decimal I'm dividing by to get it to a whole number? I'd have to multiply by 100. I'd have to jump it twice. And I'd get 2. I do the same thing to my question. And so the sum changes to 2735.4 divided by 2. Because I've multiplied both of them by 100, it doesn't change the meaning at all. You just think about it. Let's just wander over here where there's some spare space. If I did 12 divided by 4, I'd get 3. If I did 1.2 divided by 0.4, I've divided them both by 10. Let's just check. 1.2 divided by 0.4, I still get 3. If I multiplied both of them by 10, 120 divided by 40, oops, I still get 3. So as long as I do the same thing to both sides of the division, I can make my division easier, or harder in the middle case there, much more difficult. So I've multiplied both sides of my division by 100, I've got a whole number to divide by, and now I divide as I normally would. Set up my algorithm and divide. 2 into 2 goes once, 2 into 7 goes 3 times, because 2 times 3 is 6, leaving me with 1 remainder. 2 into 13 goes 6 times, because 2 times 6 is 12, which leaves me again 1 remainder. 2 into 15 goes 7 times, because 7 times 2 is 14, so 1 remainder. Notice how I put my decimal point down as soon as I get to above it, and 2 into 14 goes 7 times. And that was the answer that we checked we were going to get. So you can see that this method works. So dividing by a decimal, multiply both sides by the same power of 10, jump the decimal points the same number of times to get a whole number that you're dividing by, and then divide as usual.